Everybody, and happy Friday. So for our video lesson today, we're going to talk about identifying whether or not equations, graphs, tables, ordered pairs, etc. are functions. So obviously we're going to get into what exactly does it mean for something to be a function, how do we differentiate them. By the end, our objective is you'll be able to determine if a mapping, table, graph, or ordered pair represents a function. So let's define functions right off the bat. A function assigns exactly one output to one input. Input usually is going to be something that we label as x. Output typically is going to be represented as y. So 1x has, oh my goodness, my handwriting, has 1y. So typically we will see x and y. So if we have an x and y chart, x and y table, we look at input x and output y. We look for 5, there's only one output. For 10, there's only one output. For 15, there's one output. For 20, there's one output. And for 25, there's one output. So each input has one output. Each input has one output. So if we trace it backwards, 15, an output, has multiple inputs, but that doesn't matter. We're looking for a function, we're looking for each x input has one y output. Each input has one output, or each x has one y. So let's look at this one. I want you guys to just knowing that we're looking for each x has one y, knowing that we have x on this side and y on this side. X is input, y is output. Is this a function? Take a minute, look at it, pause if you need to. So we're going to do the same thing. We're going to go down slowly. 1 has 10 as an output. 5 has 8. 4 has 6. 1 has 4. Wait a second. Let's take a look here. 1 is here, and 1 is here. 7 has 2. 1 has 2 different y's, so no, it's not a function. We would declare this pretty clearly. Not a function. For this other one, we would write function. That would be our answer. For this one, it's not a function because 1 repeats. 1 has 2 outputs. So what's true about the numbers in the first column of a table that represents a function? We would say that, well, take a second and think. What's true about the numbers in the input side here? What statement can we make about those? Pause, take a second to think. I'm going to stretch my old man's shoulders out. So what I hope you guys noticed is if it is a function in a function, x values can't repeat. So the numbers on the left side, the inputs, the x's, can't repeat. Inputs don't repeat, or it's not going to be a function. So what if we have a list of ordered pairs? Pause for a second, see if you can figure out based on what we're looking for. Let me write it up here again. One input, x, has one output, y. So one x has one y. One input has one output. Pause and see if you can figure this one out. So we might remember xy, right? This is an x, this is a y, and so on and so forth. So I'm going to do the same thing. I'm going to look at all of my x's. Really, I'm just looking for, do my inputs repeat? My inputs don't repeat. So each input, since they don't repeat, has one output. 1 only has one output. 2 only has one output. 4 only has one output. And 6 only has one output. So this would be a function since no, I'm killing myself here, no input repeats. It's a function since no input repeats. You could put this in a table is the question, right? Couldn't you put it into an XY table? That's another way of approaching this, absolutely. So now, I want you to pause and try to figure this one out. Remembering one input X has one output Y in a function. So is this a function? Pause and try to figure it out. All right, thanks for taking a moment here. Let's look at our inputs, our x's. Do any of these repeat? I see right off the back that 0 repeats. 0 repeats. So I know if my input repeats, I would write not a function, and y, and input repeats I could put. One input has two output. One input has two output would be a reason. An input repeats. Those are all valid reasons for why it's not a function. Hopefully that's making a little bit of sense, ringing a bell from earlier in the year. So graphs. We can also look at graphs and figure out if they are functions. So let's look at with a graph. We have a cheat little code that we can use called the vertical line test. Remember, vertical is up and down. Vertical is up and down. If you can draw a vertical line anywhere in the graph and it goes through more than one spot, whether it's 2, 3, 4, 5, 6, it's not a function. So if you can draw a vertical line that goes through more than one spot, so this is an example of the vertical line test. No matter where you draw a vertical line on this first one on the left here, it's a function because it can only hit one spot. Here it hits two spots. Why does it go through two spots here? Well, because if you think about a graph, if you put this in a table, x and y, right here, let's say this is x is 3, y is 2. So x is 3, right on this line, y is 2. Down here, x is still 3, and y is -2. So here, what we really have is one input has two outputs. That's what the vertical line test tells us. So all we do is we draw that up and down line, vertical line. If it goes through twice, it's not a function. So on this example here, take a look, pause, see if you can figure out, does that look like a function? All right, thanks for taking your time. So let's try to go through. We can go through two. It's not a function. I would write not a function, vertical line test. And that's all we'd have to do because that's a justified reason, right? Let's look at two more here. Take a second and try to figure these out at home. Let's take a drink. All right, so we might notice here, pretty easy to draw a line that goes through multiple points, right? Right on this one though, there's no vertical line I can draw. They're mostly vertical. They can go through 2 points. So our one on the left is not a function, vertical line. Here is a function, and I'd write y vertical line test, right? So not a function on the left because of the vertical line test, and then on the right is a function because the line doesn't go through twice. We can also, if we get an equation, one thing we can monkey around with an equation is putting it into Desmos graphing calculator. Y equals 7x to the third plus 2. Let's go to Desmos graphing calculator. And let's type in, you might not be able to see me typing 7x to the third plus 2. Well, gosh, we can look at this. This actually, this is a tougher one to see, but this would be a function because no matter where you go on here, on a straight up and down line will only intersect this once. Let's look at y squared equals 3x plus 5. Y squared equals 3x plus 5. This one wouldn't be, because right here, couldn't I draw, let's see, this line right here is x is 20. It intersects right here. And it intersects right here, doesn't it? The same line. Vertical line could go through it twice. So the first one is a function, according to Desmos. The second one we'd say is not a function. So we can tell with an equation by graphing them. So something to really think about is if we see an equation, we could put it in a, we could try to put it in a table. We could try to graph it. We could try to put it in a little mapping, which a mapping is basically just, instead of a table, we have x and y values. We have x on this side, we have y on this side, and we'd have little lines pointing between different numbers. So it looks like a table, basically, just a little differently. So think about it. What do you like? If you like tables, make a table. If you like graphs, you could try to graph the points, right? So things are versatile in math. So go ahead and try that quiz game on determining whether or not things are functions. There's PowerPoints available in the agenda. Email me if you have any questions, and have a great day.